An interesting polar function, sine inverse of theta. So if you take a look at the picture, the graph, we've got sine inverse, then sine inverse of theta. Well, if you were taking sine of theta, then the angle could go between, say, 0 to 2 pi. But when you're taking sine inverse, so that's saying sine of something equals the theta. So if sine equals it, the biggest it would range is between -1 and 1. So in other words, if we have r equals sine inverse of theta, then sine of r equals theta, and the biggest that sine ever gets, or the range of sine, is -1 to 1, so that means the range for theta would be -1 to 1. And then take a look at the graph, and it's a little piece of a parabola, it sort of looks like. All right, convert to rectangular form, x and y. So we've got, well, we don't really have any formulas for converting, so we're going to have to make up our own. Let's see. We could use right triangle trigonometry. Here's theta. This would be x, y, and r. So we could replace the r by doing the Pythagorean theorem. R squared equals x squared plus y squared. R is then going to be replaced with the square root of x squared plus y squared. So that's what we have on the left-hand side. The square root of x squared plus y squared equals, now sine inverse of theta. Well, I could find sine of theta, but that's not the same as sine inverse. I could use tangent of theta and say, well, tangent of theta is equal to y over x. The reason I chose tangent is because it's the only one that equals something that just has x and y, because we're trying to get rid of r and theta. I could then find out what theta equals, which is going to be tangent inverse. Usually I try to avoid using the inverse trig functions when eliminating parameters or converting to rectangular form, but I really don't have a choice because that's what we're working with. So now this theta can be replaced with tangent inverse this, so we would have sine inverse of tangent inverse of y over x. That's ugly, but I don't really have a choice. So I don't really like leaving it with sine inverse, so take sine of both sides, so it's going to be sine of the square root of x squared plus y squared equals the tangent inverse. And then take tangent of both sides, so it's going to be tangent of sine of the square root x squared plus y squared equals y over x. Whew. Next, does it have a tangent line? So tangent line means you need dy dx. The slope of the tangent line is not r prime, it's dy dx. The pole means the origin. So if r equals 0, it's then going to be at the origin. So let's see. If r equals 0, we then just plug that in over here. It would say 0 equals sine inverse of theta. So take sine of both sides. Sine of 0 equals theta. Turns out that sine of 0 is 0. So we have the theta equals 0. Let's double check. Here's a little graph again. Trace, is theta equals 0 correct? Is that the origin? Yes, that part's correct. Excellent. Now we need to find the derivative dy dx. So you could either use this thing, take the derivative of tangent, leave this thing alone, do the chain rule, take the derivative of sine, do the chain rule, take the derivative of the square root, do the chain rule, take the derivative of the inside. Eventually, you would take the derivative of y squared, which would be 2y times y prime. So there would be a 1y prime over here, as well as all of this other junk, the derivative of tangent, the derivative of sine, the derivative of this. Then, on this side, use the quotient rule. In part of it, you're going to get the derivative of y, or y prime. You would then have to untangle all of that mess, get those two y primes together on one side and factor them out. By then, 2 or 3 days have gone by, so there's got to be some better way to do it. Well, the other way to do it is you use, again, if you forget the formulas, you can go back to this, find out what x equals, and find out what y equals. We've got that x is equal to r cosine of theta at all times because of this right triangle trigonometry. So cosine is adjacent x over hypotenuse, so it's x over r, then just multiply both sides by r. And we would have y is equal to r sine of theta. Then if you find the derivative of y, and you find the derivative of x, and you divide them, dy over dx, that's going to be slope of the tangent line. So in this case, r is equal to that guy, sine inverse. Over here, these two do not cancel each other out. It would only be if it said sine inverse, there was no theta right here, and this was substituted into this for the theta. It's not. These two are being multiplied. X is going to be sine inverse of theta, and then cosine. And now take the derivative of each one. So we need the product rule. Dx d theta will be derivative of sine inverse is 1 over the square root of 1 minus theta squared times cosine left alone, and then plus sine inverse left alone. Derivative of cosine is negative sine of theta. Likewise over here we would have dy d theta is equal to 1 over the square root of 1 minus theta squared times the sine left alone plus sine inverse left alone, and then the derivative of sine is cosine. Now we just need to divide them and substitute what we got for theta. So you can substitute the number and then divide them, or you can divide them and then substitute. I'm going to go ahead and substitute. So theta equals 0. So this is going to be, actually this is just going to be 1 divided by 1 once you put a 0 in. And then this is cosine of 0. So dx d theta is going to be 1 times cosine of 0 is 1 plus sine inverse of 0. Well, I believe, well, we did sine of it. Sine inverse of 0. So that really means when does sine equal 0? Or in other words, sine inverse of 0 is equal to 0. So actually this part is going to be gone. So dx d theta is equal to 1. dy d theta, again using theta equals 0, this will be a 1 times sine of 0 is 0. Sine inverse, that's going to be also a 0. So then we have dy dx comes from dividing these two, so this one is a 0 and this one is a 1. Amazing, we did all of that work just to get the numbers 1 and 0. So dy d theta over dx d theta, so the derivative is equal to 0. And one quick look at the picture would have told us that a long time ago, because at the origin that would have a horizontal tangent line. A horizontal tangent line has a derivative of 0. One more way to check, dy dx when theta equals 0 is 0.